knowledge management. I'm going to talk to you today about critical path analysis. We're here in Aberdeen in Scotland, our usual base for making these small knowledge granules, and this particular one is one of three excellent techniques in project management: earned value analysis, critical path analysis, and the work breakdown structure. These three things are fundamental to project management, and this is a simple explanation which takes a few minutes, which will allow you to understand what you need to know about the theory of critical path analysis, and will help you with your use of the excellent software products that are out there, Microsoft Project, Primavera, etc. Probably over 100 different software packages out there, and all of them use this theory. I'm not going to use building a house or making a meal. I'm going to make an abstract job up so that we can concentrate on simply the basic mathematics of what we do. So I'm going to have a series of jobs that I do called A and B and C and D and so on, and I'm going to enter the jobs in simple boxes like this. I'm drawing these cells around them, and I'll explain each one of those as we go along. And that is a job A that we need to do, and we need to do that job before we do some other job B. And I'm going to call this B my job description. Just tells me what's going to be in there. So I've got A, B, C, we'll throw in a D. I'll make them up as I go along. So that's D, and we'll have a few more. So I'm using it in alphabetical order: E, F, and we're going to have a G, okay, H, and rather than use I, which will probably confuse everybody, we're simply going to call the last activity in this sequence J. Now, how are we doing all of these jobs? I'm not going to talk about the time at the moment. I'm going to talk about the logic or the sequence. And what I'm telling you about the sequence here is we cannot do job B until we've completed A. So we draw a relationship between B and A like that. B cannot start until A has been done. Similarly, C cannot start until A has been completed, and D cannot start until A is completed. Now there's no relationship between B, C, and D. There's just a relationship between A and B, A and C, and A and D. That's how that works. And so we can go on from there in a slightly more complex logic, if you like, and this technique is used for building enormous projects. So let's say that we cannot do E until B has been completed, but we also need D completed before we can do E. And you can see I've drawn that relationship, that constraint, it's sometimes called, or restraint, from D to E. And it's the finish of D and the start of E. And we'll also say we can't do F until we've completed C. Okay, that's what we got so far, building up this logic. We can move on from there. We can't do H until E has been done, and we can't do G until F has been completed, and also we can't do J until F has been completed, and we can't do J until J has been completed, and also H. So that's the logic. That's the sequence of activities. These could take on a more realistic term when you think of, like, you can't lay the pipeline to connect a water supply to a domestic premises unless you've dug the trench and then lined the trench, for example. That's an implicit logic in that. So that's where these things come from.